Alright, let's do this. Unit 3, Worksheet 4, Freefall Problems. Number 1. Upton Chuck, riding the giant drop at Great America, and he starts from rest. And we're going to start our work with a diagram. Whoops. So, we're going to have Upton starting at a velocity of 0 meters per second. Time is in seconds. And he'll start at 0, and he's falling down. Woo! And so that's what our diagram's going to look like. Very basic for now. Known and unknown values, and this is where these free fall problems get a little bit trickier than our other ones, because there are values that are not stated that we can still discern. So the thing that is stated explicitly here is that the time of free fall is 2.6 seconds. What's not stated is things like, what was his initial velocity? Well, he starts from rest, so while it doesn't actually give the number 0, it's assumed that the initial velocity being at rest means that his initial velocity was 0. And it also doesn't state the acceleration. The thing about that is that this is a free fall problem, and we already know that the acceleration due to gravity on Earth in free fall is approximately -10 meters per second squared. So these problems, anything where an object is flying through the air or falling or being kicked and is up in the air, or anything like that, the acceleration is always going to be our -10 meters per second squared. You are free to use -9.81 if you'd like, but that just complicates things a little more than I like. Close enough to 10, we'll use 10. So then the question asks, what will be his final velocity? So v final is an unknown that we're solving for, and how far will he fall? So that's looking at displacement. And those would be my unknowns. So now we're 50% of the way done with our problem, right? Looking at variable form equations, let's start with that final velocity. I know that final velocity is initial velocity plus acceleration times time, which is a very straightforward equation to use and convenient because I know everything that I need to solve for v final. Started at 0 meters per second. Acceleration was -10 meters per second squared. And he fell for 2.6 seconds. Checking out our units, seconds will cancel with one of the seconds on the bottom. So what we're left with is that his final velocity when he gets to the ground will be -26 meters per second. And that makes sense because what acceleration is change in velocity per time. So 10 meters per second. Every second, his velocity changes by 10 meters per second. So after the first second, he'll be moving 10 meters per second down. After the second second, he'll be moving another 10 or 20 meters per second down. And after 6/10 of a second, he'll be moving an additional 6 meters per second down. So there's my solution to the first question of this problem. How fast will he be moving at the bottom? The second part asks for his displacement, or how far he falls over that time. So I like this guy, 1/2 at squared plus v initial t, which is convenient because in this case, v initial is 0, so v initial t cancels to 0. And what I'm left with on the left side is 1/2 times -10 meters per second squared times 2.6 seconds squared. And that's the displacement. So we'll square our 2.6 seconds, multiply that by our -10, multiply that by 1/2, and we get a displacement of 33.8 meters in the negative direction. the question doesn't ask his displacement necessarily, it asks how far he falls. So how far is a distance, and so technically speaking that should be a positive 33.8 meters because distance can't be negative. But I would accept either one of these answers. And there we go.